Okay, hello. Can you hear me?
Yes, you are audible.
Okay. So I share my screen. Can you see my screen now?
No, it is not visible. Just take some time in Google Meet. Okay, now it is
Okay.
sharing.
Okay. Today is your third day class, yeah?
Yeah.
Okay. So
Kindly record the class.
yeah, I start the recording. No problem.
Okay.
So hi and welcome to the 7 days online training session on Google Earth Engine from beginners to advanced. So I am course coordinator. So basically today is our third day class.
Hmm.
We already covered the first day and second day. Today is our third day class, and this is our full course content. Within the 7 days, we completed the total full days, all of the course content within the 7 days. And today is our third day. Third day's course
Okay.
content will be that. First of all, I will try to discuss about that how we can easily filtering and displaying the satellite images. Sentinel 2. In this time, I will try to show you that Sentinel
Okay.
2. Okay. Then how to make the NDWI using this Sentinel 2 satellite imagery. I also try to show you that part. So then how to make the NDVI time series chart. Okay. Then
Okay.
how to export any shape file. Okay. Then calculating any indices from satellite images, and how to add the gradient legend, and how to monitor the land surface temperature monitoring. So mainly Landsat and Sentinel modis, we will try to show you the both things. Then how to calculate the modis and Landsat data, and for the calculate the normalized difference water index. This is our third day's course content. So let's start. So first of all, filtering and visualizing the satellite images in Google Earth Engine platform. And previous class, you already completed the Landsat, yeah?
Yes, yes.
Okay,
Lancet.
yeah. So today I also try to show you this part for Sentinel, how we can easily filtering the Sentinel image, and then we also try to show you that how we can easily calculate the NDWI. Okay.
Okay.
And in this time, it is the same process when you want to filtering the Landsat or Sentinel. It depends on the some factor. Okay, this factor it depend on your, suppose in depends on the region. Suppose you need to the Landsat images or Sentinel images in a region, in a specific region. Okay, and we already know about
Hmm.
that. We can easily import our shape file, and we can
Hmm.
easily create the region. Okay, so in this time,
Hmm.
this is the factor, one factor for the region. Another factor can be suppose image properties. Suppose you need the image on less than 1% cloud cover or 2% cloud cover. Okay, so it's the specific image properties. We can easily filter these image properties, and we can easily get these images. Okay, so in this time, this is the another factor. This is the filtering the image properties, and another factor is the time duration or any specific period. Okay, so in this
Hmm.
time I will try to show you that Sentinel 2 satellite imagery, how you can easily filter this imagery, satellite imagery for any specific region, and then how you can easily calculate the NDWI or normalized difference water index using this satellite imagery. Okay, so for this, okay, so we will try to go to our code editor and then show you the practically. So I simply open my code editor. So in this time, here you can see I open my code editor and then I simply search my specific dataset. Suppose in this time I want to need work the Sentinel-2 dataset. So I simply click on the browse data catalog. Here I can find all of the dataset and we can easily work with the Sentinel-2 satellite imagery in here. So in this time I simply imported this image. I simply click on the Sentinel-2. Here I can get all of the collection of Sentinel-2 satellite imagery. So in this time I also try to show you that. So here my network connection is not so good, so it takes time. Okay, wait a minute. So
slow network connection.
Yeah. Okay, so in this time I want to use, here you can see I want to use here the Sentinel-2 multispectral instrument. I simply click to here. So in this time here I can get all of the collection of the multispectral instrument, and I want to use here the Sentinel-2 satellite imagery. So I simply open this satellite imagery in here. So here you can see atmospheric and surface reflectance. I want to work with the top of atmospheric dataset. Okay. So here you can see all of the information about this dataset. This is same. You can see this is the dataset availability date. We can easily access the Sentinel-2 dataset from the year of 2015 July. Then we can also get the, this is our present time, we can easily access. Okay, so in this time you also see the dataset provider. Okay, so in this time I want to use this dataset and filter this Sentinel-2 imagery for my specific region, and then I also make the NDWI or normalized difference water index map. Okay, so first of all I simply copy the Earth engine snippet from here. This is my Earth engine snippet. I simply copy and then I simply paste in my code editor. So this is my code editor, simply paste. And then in this time I need to create a variable name. So my variable, I can simply use the variable name is that, you can use any variable name. Okay, so in this time I use a variable. Suppose this variable name is the Sentinel-2. Okay, now this Sentinel image collection is stored in my code editor. Okay, so it is stored. So in this time, suppose in this time I want to create the NDWI map for the 2 season. Suppose I want to create the NDWI map for the wet season, as well as I also calculated the NDWI for the rainy season. Okay, or dry season or rainy season. Okay, dry season and rainy season. I want to calculate the two season NDWI. So for this, first of all I need to filter the image according to this 2 season. Dry season and wet season. I want to filter this date. Okay, so I simply take a variable. Suppose I take the variable for the image, suppose dry season. I simply use here the image dry. So first of all I call my full collection Sentinel-2 and paste here. After this, in this time I need to use here the filter bounds function. Filter bounds, wait a minute, I use here the filter bounds with my region of interest. Okay, you can see I simply, in this time I simply import here my region of interest. So my region of interest is that I simply imported here the, suppose I want to work with the Dhaka city, I simply put here the Dhaka district boundary. You can see I simply import and give the name, this is my ROI. Okay, so I simply paste here the ROI. Okay, in this time you can see this is my image dry season, and here we can see this is the sentinel 2, it will be intersecting with the whole collection, with my filter bounds. My filter bounds is that you can see my ROI. I simply put here the ROI. Okay, so I filter according to my region. Okay, so then I also need to filter the specific time period. Okay, so I simply use here the filter date function, filter date, and I simply put here the start date and end date. Suppose in this time I need to use here the date for the dry season. So for this I simply put here the dry season date. Suppose I want to observe the year of 2020, I simply put here the dry season. It will be start from the January, and from I also put here the dry season January, February, March, April. So April, so I simply put here the 2020 April, then suppose 30. Okay, so I simply put here the dry season date or dry season period. This time dry season in Bangladesh, January to April. So commonly this is the dry season, and I use here the dry season in this time in here. Okay, then I simply use here the function, this function called the short function. If you want, you can use here the filter metadata, no problem. If you want, you can use the filter metadata, and then you can put here the image properties name. So in this time also you can see image properties, different types of image property, cloud pixel percentage, cloud coverage assessment. Suppose you need the only for those images which image will be not more than 1% cloud pixel percentage. Okay, you can then you can simply use here the cloud pixel percentage, this image property name. Okay, you can simply copy and then you can simply paste here. Just this is your image properties name. I can simply use here. Okay, then you can simply put here the less than operator. Operator is the less than. You can simply put here the less than. Suppose I can simply use here the less than, and then you can simply put here the value is 1. Okay, so in this time when I can get run this code, I can get only for those images which image will be not more than 1% cloud cover. Okay, in this time I can get only for those images which image will be not more than 1% cloud cover. Okay, so in this time here you can see I can use the filter metadata function, but it has the another function. Instead of the filter metadata, we can use the another function. This function name is the short function. Short, you can see in this time I use the function because we already use the filter metadata function for the length set. Okay, I simply use the short function. So short is a function. It will be short the element of the array along one axis. So element in this time, this element can be image properties name. Okay, so this element can be image properties name. In this time my image properties name is that, I simply put here the image properties name is that cloud pixel percentage. Okay, and then I simply use here the false. So in this time I get here the less cloud pixel images. This image will be sorting or indexing according to the less cloud pixel percentage. Okay, so I simply use here the false function for this. And then how many images I can get from here, you can see I want to check it. I simply use here the print function, and then I simply call the image dry function, and after this I simply use here the size function. It's determined how many images will be available between this time period. Okay, with less cloud pixel percentage. I want to check it. So here we can get 72 images I can get. In this time I want to use here the another function. You can see when you want to use here the mean, median. Okay, in this time I want to use here the mosaic function. Mosaic, you can see mosaic is a function. It's composite all of the images. So created the all of the images in one composite. So in this time I simply use here the mosaic function, and after this I simply use here the clip function. Clip with my ROI. Okay, clip with my ROI. So in this time I can get the image for the dry season. Okay, for the Dhaka city, Dhaka district. In this time I simply copy this code and I simply paste again in here, because I need the two period image.
Wet season.
Dry season and wet season. Okay, I simply copy and then paste here. I simply change the variable name. Suppose this is the wet season image. I simply use a wet. Okay, Then I simply change the duration or time duration. So mainly the rainy season or wet season in Bangladesh, it will be start from the year of January, February, March, April,
June,
May,
September.
June. I simply put here the June.
June to September.
Yeah, so June. Okay, so I simply put here the suppose October. Okay, between this date, this is the rainy season. So I can use this here. So this is the image wet season. So and dry season. I can get the two collection or two satellite imagery or two period. First period is the dry season and wet season. In this time I want to show the map on my map interactive view. So I simply use here the map.add layer function, and then I can simply use it. So I simply use here the map.add layer function, and then I simply call the image dry. This image I simply call and paste here. After this I simply run this code. We can see, okay, we also need to add here the map center object function, because focusing the center of the shapefile of Dhaka city.
Yes.
So I simply use the map center object function, and this is my ROI, and put here the zoom level is the suppose 9. Then click to the 9, click to the run. Okay, sorry, this is the comma sign. Now click to the run. Okay, so we can totally get the totally black color image because we did not add any visualization parameter.
Okay.
In this time I simply add the visualization parameter. You can see all of the band will be available here. I simply use here the band suppose B4, B3 and B2 true color composite, and I also increase the stress suppose 98% for better visualization, and then click to the apply. Then I can get the image. You can see this is my dry season image. I can create the dry season image, and in this time I also need to import this image visualization parameter in my code editor. Okay, so I simply click on the import. You can see, click on the import. So now it will be imported. I simply copy the name, and we already know about that. This is my object. After the object we always put here the visualization parameter name, and then I simply put here the layer name. I can simply put the layer name is that image dry season image. Okay, so I simply use here the dry image. Okay, now it will be okay. So I also simply copy this code again from here, copy, and then I simply in this time simply call the wet season image. I simply copy the variable name and paste here, and I also change here the this is the wet image, okay, or wet season image. Then simply click to the run. So in this time here you can see we can get the two layer of the satellite imagery in here for Dhaka city. So you can see
cloud.
yeah. So in this time here you can see we can get the two images of satellite images, dry season and wet season. And you can see rainy season or wet season, there is a lot of cloud. Okay, there is a lot of cloud. For this is the rainy season, rainy time. Okay, so there is a lot of cloud. So in this time we can also easily remove and cloud and haze from our satellite images, and we can get the clear image. So in this time I will not discuss it. I will try to discuss the cloud remove function the next classes. Okay, so we can easily remove all of the cloud and haze and get the clear imagery of the rainy season also. Okay, so in this time you can see I use here this image. I can get the two images, dry season and wet season. You can say dry season is the very clear condition. There is a no cloud or other things. But when I open the wet season, here you can find a lot of cloud. Okay, but Google Earth Engine has a function. We can easily use the function and cloud max function. Then we can easily remove all of the cloud and haze and get the very clear satellite imagery. So I also try to show you the next class so that you can easily understand all of the things. So in this time you can see I can get the two images, two period images, and I also need to calculate the two period NDWI, dry season NDWI, as well as also calculated the wet season NDWI. Okay, so it's very easy. So I simply calculated the NDWI. So I simply NDWI. So in this time, first of all, you should know what is the calculation of the NDWI. What is the formula of NDWI? So NDWI formula is that green band subtract with near infrared band divided by sum of the two band, green plus near infrared band. Okay, so in this time here we can see all of the band description in here. So here you can see green band, this is the B3, this is the green band, and also you can see B8, this is the near infrared band. I used the two band and calculated the NDWI indices. Okay, so for this in this time I simply take a variable. Okay, so take a variable and give the variable name is the suppose NDWI. First of all, dry season and wet season. I simply use the dry. So in this time I calculated the NDWI for dry season. Okay, so for this I simply call my dry season satellite imagery. So here you can see my dry season satellite imagery is stored in a variable. This variable name is the image dry. I simply call the image dry and then I simply paste here. Okay, in this time I need to use a function, this function called the normalized difference. This is the function normalized difference. Okay, so normalized difference is a function. It's calculating the ratio, or it's calculating the equation of near minus red, green minus near infrared divided by green plus near infrared. Okay, you can see I open this function. What is the description of this function? I simply open it. So from the docs tab I simply open it. Here you can get the description of this function. You can see the normalized difference is computed as the first minus second divided by first plus second. It means that in this time I need the two band B3 subtract with B8 divided by B3 addition with B8. Okay, so when I use the function, it's automatically calculated this thing. Okay, so in this time I simply use here my band name. So I simply put here the band. I make a list of band. So I simply use here the band and then make the list. So my band is that B3, this is the green band, and I also need the B8, this is my red band, near infrared band. Okay, so here you can see I simply calculated the normalized difference for the dry season. I simply copy the code again from here and then I simply paste here. After this I simply change the variable name. Suppose this is the wet. Okay, this is the wet season, and then I also need to call the wet season image. I simply copy the wet season image and paste here. Okay, so now I calculated the NDWI dry season and wet season. I want to show the two layer in my map interactive view. I simply use here the map dot add layer, and then I simply call the NDWI dry season, as well as I also add here the visualization parameter. Suppose I make the dictionary. I simply use here the curly bracket. So I want to show the mean NDWI pixel value. It will be start from the -1 and up to max pixel value. It's showing the +1. Okay, and I also show the color plated as a. I want to show -1. This pixel value or closer to the negative this pixel value will be showing as a I can show this color as a, suppose for the NDWI, what we can say, for the NDWI range positive value or higher positive value, it's identify the water. Okay, so positive value, suppose 1. Okay, this 1 or closer to the 1 or positive value, this identify there is the surface on the water. Or negative value, it can be urban, it can be actually can be vegetation or other things. Actually there is the no water. When we can find the negative pixel value, it means that there is the no water body. It can be vegetation, it can be urban body, it can be other feature, but there is the no, we confirm that there is the no water. But when we can get the positive pixel value, it's identify there is the must water. Okay, so in this time I want to show the negative value as a, suppose I can simply use here the negative value, I can simply use here the green color. Okay, then I also need to add here the also suppose white color. You can use any color, no matter. And I also want to show the blue color. Okay, so it means that you can see blue it represented the pixel value of positive pixel value or closer to the pixel value, and it's identify our water bodies or water surface on the, okay. And white, suppose less than, you can see what is the water meaning, white color is represented which pixel value will be greater than -1 but less than +1. This pixel value will be showing as a white color. And green color, which pixel value will be negative or closer to the negative, it's showing the green color. That's it. So I simply copy the again from here and then simply paste here, and then I simply call the NDWI wet season. I simply copy and paste here. Okay, I also provide a layer name in here. Suppose this is the NDWI for dry, and this is the same thing for the NDWI for wet season. Okay, so we can calculate the 2 period of NDWI for the region of Dhaka district. Now we can get here the total, you can see we can get here the total 4 layer. So now you can see
layer 2. Yes.
Okay, so now you can see in this time, so here you can see the dry season, there is a very less water pixel value, you can see for the dry season. But wet season or rainy season, there is a lot of water pixel, you can see. Okay,
Yes.
you can see this is the wet season NDWI. There is a lot of pixel value, water pixel value, and also you can see this is the dry season NDWI. I simply, you can see this is the dry season. There is the very low NDWI, or there is the very less water surface in the Dhaka district. So now you can see here the NDWI wet season. You can see there is a lot of water body. I want to check the what's the value of the pixel value. You can see I simply click on the water body. I can get the positive value. You can see for the water body I can get here the positive value. You can see 0.4.
Right.
Okay, 0.4. But also you can see I can get the negative value. It means that when the dry season there is the no water in this place. Okay, you can see the latitude and longitude also provided. In the dry season for the coordinate there is no water, but when you can check this wet season, here I can find the water pixel value. It means that it is a negative. Okay, so here you can see there is the water in the also water. Okay, so actually there is the water will be in, we can easily access the water pixel value for the Dhaka district. And if you want, you can easily export this map as a TIFF format, and you can easily make the not only for the NDWI. If you want to need the other indices, suppose NDVI, you can just put here the what is the equation of the NDVI, what's the band of the equation. You can just put the equation, then you can get the NDVI map for the Dhaka district. This is the same process for any indices. We can just change the band name. Okay.
Okay.
So in this time you can easily export this map. We already talk about that. You need to use here the export image to drive function, then put all of the argument, then you can easily export this. Okay, so we can easily export this map and make the map layout or other things. So I hope you can do it, make the map layout. Okay. Okay, so I hope you can do this. So in this time I escape this part, so I hope you can easily do it using this ArcMap software. Okay, and do it for your map presentation work or research work. We can easily do it.